Here we have been asked to use compositions to show that f of x equals 6 over 7x plus 1 and f inverse of x equals 7x minus 7 over 6 are inverses. To do this, we must first show that f composed with f inverse of x gives us a result of just x, and then we must show that f inverse composed with f at x gives us just x as well. So always do this using two steps. First, showing that f composed with f inverse, we would want to say the first function that we're interested in is our function f. The innermost function would be the f inverse. So from here, write down in general what f looks like, but in place of x, just leave a big set of parentheses. So this is what f looks like in general. You take 6/7 times something plus 1. Now, in place of the x, we're going to put f inverse, which is the 7x minus 7 over 6 function. Now, from here, be careful as far as the order in which you do your cancellation. We have a 6 on the top that would cancel with the 6 on the bottom, and so we can go ahead and reduce those two. So we would have 1/7 and then 7x minus 7 left on the inside, and then plus 1. Now distribute the 1/7. 1/7 is the same thing as dividing by 7. So this becomes 7x divided by 7 minus 7 divided by 7, and then plus 1. Well, the 7s would cancel. So we would have x minus, here be careful, the 7s do cancel, but they cancel to a 1. So we'd have 7 canceling there and leave us minus 1. And then we'd still have the plus 1 at the end. Now the -1 and positive 1 would cancel, and we're left with a result of just x. Now, we must receive as our answer just an x when we do our first composition. However, getting x in the first composition is not enough to show that these two functions are indeed inverses. You also have to show that the reverse composition also yields x. So let's go and do that. So as our second step, f inverse composed with f of x. That means the first function we are interested in is f inverse, and then into that we're plugging in the function f. Well, what did f inverse look like? It looked like 7 times something minus 7 over 6 from up above. So if we look back at our f inverse function, then here's what we have. So 7 times x minus 7 over 6, we leave a set of parentheses where the x is. And then in place of that set of parentheses, we want to substitute f of x. Well, f of x was 6/7 x, and then plus 1. Okay, now we're interested in simplifying. Here, there's nothing that would cancel out right away, so I'll go ahead and do the operations. Here we would want to distribute the 7. So we would have 7 times 6/7. The 7s would cancel. So that would leave us with 6x. And then 7 times 1 would be 7. And then we still have a minus 7 on the top and then a 6 on the bottom. In the next step, the positive 7 and negative 7 would go to 0. So those would cancel. I'd be left with 6x over 6. And then that now reduces to x. So what we have found is we have found that both of our inverses, our compositions, simplify to x. That being the case, we would say, so f and f inverses are indeed inverses. The logic behind this is that whatever the function does, the inverse undoes, and vice versa. And so if you compose each of the functions with themselves, the original and the inverse, then both should yield only x. but you have to show both directions to be able to verify that they actually are inverses.